Oh, hello!
Oh,
Hey, that was perfect.
Brian has saved me yet again. Oh my goodness. Hello to all of our
Did you forget
viewers.
how
I forgot how to touch a button. That's what I forgot. Hello to all our viewers. Thank you for staying with us during those technical difficulties. We're now back online.
Oh, there it is.
The stream is running at like at least a 20-second delay. So if you guys have questions, please post those. We'll get those to you as soon as possible.
That's about 20 seconds after you post the questions.
That's about right. So if you do have questions, don't expect a less than 20-second response, but we will happily get to you guys on those. And feel free to reach out with questions at any time during the stream. Alright, so I think since this is our first informational stream, we're going to go around and introduce ourselves. So if Alex, you'd like to start.
Yeah, I'm Alex, student at electrical engineering major at Georgia Tech, and I'm leading the navigation design for the robot. So working on a lot of antennas and some phase comparison and filters and stuff like that right now.
Hi, my name's Josh. I go to the Kent State University in Kent, Ohio. I'm studying aerospace engineering, and I'm working on manufacturing, design, supplies, stuff like that for the boat. So I was actually able to go down to Florida for the testing, so we have some pretty cool footage to show you guys.
besides his visual being a little bit lagging behind, yeah, I'm Justin Knelson. I'm over here at South Plains College, and I'm the guy that printed the darn boat. So I got that done.
That thing right there.
Yeah, that big old boat. Yeah, I built that. Other than that, that is me. Yeah.
All right, Brendan, you want to?
Brendan.
Hello, and my name is Brendan, and I'm a sophomore in the aerospace engineering program here at Embry-Riddle Aeronautical University. And I'm serving as another one of the team members here on the Daytona Beach side of things on this Micro-G Next EGgBOAT project.
Hi, I'm Brian Weed, electrical engineer at Embry-Riddle Aeronautical University. Same as Brendan, helping out with the manufacturing side of things over in Daytona Beach.
And my name's Jacob Shudik. I am an aerospace engineer here at Embry-Riddle, and I've been working on a lot of the design and testing for 3D models and then shipping those over to Justin to get printed, which has led us to the creation of our mighty EGgBOAT, which is very exciting. So, happy to have participated in that much. And I think Josh just today got some excellent news. Josh, would you like to brief our stream here on what happened today?
Oh, so other than being an aerospace engineer at Kent State University, I also do Air Force ROTC. So I'm going through the training process there at the college to hopefully my dream is to become a pilot in the Air Force. So I just got news today that I was selected for an enrollment allocation and I get to go down to field training at Maxwell Air Force Base this summer, and I have a guaranteed spot as an officer in the U.S. Air Force. So pretty cool. Go Air Force. I'm super thrilled. So it should be pretty awesome.
Good stuff, Josh.
Good job. You did well.
It all pays off. If only that was as impressive as EGgBOAT. Now. Just kidding. We love you, Josh. Thank you. Good stuff.
Good stuff.
Alright, so just as a briefing of what we've been doing lately, EGgBOAT has been constructed.
Behold the boat.
And we decided to start water testing after we got our motors in. If you want to see our process on those a little bit, you can check out our build videos on the YouTube. Those will exist in that frame there. But past then, once we were done with those, we've started doing water tests. And we immediately noticed that the boat doesn't boat very well. Brian, would you like to elaborate on that a little bit?
So the water was quite literally seeping through the walls, getting into the main hull. After leaving it in for about, I think it was 15-20 minutes the first time, we did a bathtub test. It was about halfway full with water. It was over the water bag. So we did the next best thing, and we used Flex Seal.
The whole boat is now, at least the underneath of it, has now been coated in Flex Seal. And so the idea of that was to pray to Phil Swift that we might have a solution to make the boat more of a boat. And so we had a deadline for this previous Sunday to conduct our first float test in anything other than a bathtub. And so that was our first timeline goal that we met. And with the Flexi Seal, we were actually able to meet that. And so we've got some footage from that day and how that went. And I think we're just about ready to present that to you guys. What do you guys think? Everybody?
I think so.
Yeah.
Let's
Which,
roll the-
for reference, isn't that thing still epoxied as well? So we got like
Yes.
Flex Seal and epoxy on it. Yeah. So
And then we're gonna
Waterman.
Flex Seal the inside yet to further reinforce the inside of the holes, just to keep every single droplet of water outside.
Maybe even add more Flex Seal.
That's right. We might just like put a bottle
Get
of
the Flex
Seal
tape,
in it.
On
Flex
the
Seal,
inside. Yeah,
Flex
use
paint.
Flex tape, Flex Seal. We got.
The whole product. Patch, bond, seal, and repair. And
You
we-
know, maybe even take out a loan from Phil Swift while we're at it.
if we can
Anyone
get a
got Phil's
sponsorship
number?
from Phil Swift, yeah. Somebody ring him up. That'll work. All right. So with that, we headed over to the Embry-Riddle Fitness Center pool for our first water test, and the footage of that went very well. But we've got two video presentations. It's on this side. To show you guys. As you can see, we've moved to the power test section. It's super exciting. Super important part of the stream. We're going to show you
We're
guys
getting
those
ready.
videos now. Alright. Sit tight. Grab your popcorn and here we go. Brian, you're on catch. Very excited for her. That's why I brought this in.
Nice. Well, we know it moves. How fast can you spin it in a circle? It does tricks. What?
Wait, quickly, this is the most fast floating space symbol ever.
Oh, yes, it is.
You gotta get that color in it. Oh, that 360 can't focus.
Yeah, it is. I can stabilize it. Wait, that is going through all the loading. Alright, so as you can see there, the boat indeed is moving, and that's a very good thing, but there's something that went very wrong in that first test. That was the first point we put it in the water in a powered circumstance. I think Josh might have some insight for us on what happened there. You want to explain how we achieved such an angular velocity there? It was quite impressive.
Yeah, so it's pretty simple. We don't have the capacity currently to steer the watercraft. We don't have the mix set up on the transmitter, so we're not able to program which motor goes in which direction at what time. So the way that we worked with our motor direction was through the ESCs. And depending on the way that you plug in an ESC, depends on the way that the brushless motor spins. So the way that we plugged them in for our initial trial, we plugged them in oppositely, so one was going full forward, the other was going full reverse, and thus we had a nice spinning watercraft, which was kind of fun to laugh at and play around with.
Yeah, and if you guys want to check out our social media accounts, we've got a couple different good videos of that on Instagram and TikTok that kind of
Especially
elaborate.
TikTok.
Yeah, there's some good videos that we were able to make out of our spinning boat phenomenon there that occurred, but we decided that it's probably best to not keep it in that configuration for the entire test, so following that we took it out of the water, we put it back on the test stand, readjusted the motor wires, reconfiguring 2 of the brushless poles to reverse the direction of the faulty motor, and then put it back in the water. You guys ready to see the actual test footage of EGgBOAT moving in a somewhat forward direction? We good?
Yes, moving in a straight line. is
Send
always
it, Chief. Send it.
That's right. Let's see that footage.
Okay, well, the R6 is set. Actually, Brendan, you want to go check it for a sec? Sure that it is.
Okay, Brian's in the pool for it.
Kind of hard to change.
Yeah, what if you try holding it in one spot?
Something like that. That's half throttle.
Pushing Brian.
Hang on, at least we
This
know.
isn't full yet. That's 3/4. Don't go for it. Rack test. It's pretty stable.
Nice.
What was that?
Haley is what that was.
That thing how's out.
Hold tight. Because now he's the one that works at it.
That's exactly it.
Yeah, and then
I don't know if there's a big
I mentioned the possibility of wrong type system like that, he was saying that this happens with other surgeries and basically I somehow spread the virus to my eye.
Like, try and, like, put some nose down.
in my eye or whatever.
No, just like
And that's why the guy turned it over.
and do it with the bag too.
Yeah.
Go back. back.
So I just basically cleaned up.
You can try and go side too.
Like side to side.
Later this
That's
afternoon,
not
I can probably go by public and get that.
Find the back pipe.
From what I can tell, you know. When you look underneath, do you see the water going back out forward of the same insert
It's going backwards?
when we go backwards?
It should. Oh yeah.
Yeah, that's good news.
Using it as
Not
a
to let me
life
turn it around
preserver,
once I get there. but-
how would that work?
Like I mean, it could be battery. Like we just used all the battery on one side, but ooh,
I not see the suit.
Oh yeah, the backside. Yeah. Well, it's almost like we do kind of know what we're doing. So as you guys saw in that video, Josh thinks it's funny. As you guys
agree.
saw in that video, EGgBOAT performed a successful first power test. Now Josh alluded to this a little bit in the first bit of our info session here, but we did not have the steering hooked up yet. We're running on a single dual channel RC remote and it didn't have any mixing capabilities for us at the moment. We're going to work on changing that in our next powered test, but that'll be coming up after in at least 2 weeks. Got to go get the controller for that. So
Yeah, so basically its control system during that test was pretty straightforward. Literally, forward and backwards.
Yeah. Yeah.
I
Yeah.
know what you did there.
With a little bit of turn because went and looked back at the craft today and on the left thruster, the reason why it was moving to the left all the time.
Ooh.
Test analysis now. So and
Segue.
so we went and looked back at the thrusters, and when we were sealing off the thruster vent, yes, the output, you would call it, the RTV, there was a lot of overflow inside, so it was blocking the actual amount of water from getting out, causing a choke in thrust.
Yeah, and so today we were fortunate enough to see that Brian cleared out that mess of RTV in the back of the thruster, so we should be at least closer on our directional, but as soon as I attain a trimming and mixing enabled controller, we'll be able to drive quite straight, and in different directions too. It's a crazy concept, but we'll be getting to that soon.
Yeah, how can you
That's
imagine a boat that can move more than just 2 directions?
That's crazy.
That's
Like on
whack.
multiple axes. That's awesome.
Wow.
Dude,
Almost like an
imagine if
airplane.
it did that, but also by itself.
I can't imagine that. That would be crazy.
That'd be pretty hard to do, wouldn't it? That'd be pretty
Do
impressive.
you think we could do that?
Impossible.
Should we try?
Yeah, I
I
think
think
so.
I think
I think
we
that's
should
what
try.
we should go
That's
for.
that's
yeah.
a good goal. What do you guys think? Everybody in agreement?
I don't know, man.
Yeah, I
Can it
think
also
so.
go vertical? Can it go vertical, man?
Oh,
You gotta make it go
multiple
vertical.
axes, not every axis. It's we gotta draw the line somewhere.
I mean, we could make it fly, but that wouldn't be exactly
Go
part of the
straight to the
competition.
astronauts. As soon as they abort,
That's right.
it's gonna go
It's just
straight
gonna
there.
rendezvous with the flying capsule. That's right. All right, so I think our next goals are to do another further powered test with a turning vessel and trimmable vessel. We'll see once we get it going in a straight line. At that point, we might be able to actually clock in some speeds on EGgBOAT. It already moves pretty fast. It was able to push Brian across the pool.
That was something amazing.
Yeah, that was pretty
pretty
impressive. We'd also like to note how it was able to keep out 90% of the water it came in contact with. That's right. So if we did this amazing test, I'm totally not lying about, where we laser measured all the molecules it came in contact with, and we kept out 90% of those. Not
yeah.
sure. But what we do know is that both the side hulls, when we were done with the testing, you saw that we did some splash testing or wake testing, and the side hulls stayed completely dry. They were patch bonded, sealed, and repaired by Flex Seal. The inside hull got a little bit of water in the middle, but we're looking at patching up the inside of that as well too, so we should be good by then. Yeah, so we've got a couple questions in chat I'd like to address. The first is one from Janice Shudik. We don't know where she's from. She's just popped into the chat. Surely has no relation to any of us, but I'm sure she has a useful question here. She asks, navigation update, please. I don't think that counts as a full sentence, but I think Alex might be able to update us on where we're at.
Yeah, so navigation is coming along. It's just very complicated, especially because of lack of prior experience with antenna design and RF design in general. So a couple weeks ago, started and created prototype antennas. Antennas have to be designed for a couple of different parameters. First, we want to optimize how it receives signals from different spaces. That you can have an antenna that, like, from a certain direction, it'll receive signal at a certain power, but in a different direction, it'll receive signals from there much less powerfully. We wanted to design what's called an omnidirectional antenna, which can get it from all directions equally. So we went for a helical antenna for this design. But then secondly, we want to make sure that when the signal hits the antenna, that it can be, the energy can be converted to electric signal as efficiently as possible. So this is matching what's called the internal impedance of the antenna. It varies over frequencies, so we wanted to design it to make sure that it operates well at 121 megahertz. So it was a lot of trial and error for getting a design with that, but eventually got a 3D printed case, or I guess model, that we wrap a wire around, and we can get reliably an antenna that works well at 121 megahertz. So that got finished up this past weekend, creating all the antennas. The next step from there is that while it really effectively picks up 121 megahertz, other signals can also get picked up. So we want to filter those out. And this is done by using what's called a bandpass filter. It just uses capacitors and inductors to attenuate signals at various frequencies, and you can, by choosing the capacitor inductor values, you can choose what signals you want to let pass, which is known as the pass band, and we want to design that around 121 megahertz, and which ones are stopped, which is known as the stop bands. So this past weekend was also working on that. Designing filters like this is not usually very complicated at lower frequencies, like in the tens or hundreds or even kilohertz. But when you get into the megahertz ranges, individual components behave non-ideally, meaning an inductor will normally, at smaller frequencies, you don't have to worry about small parasitic capacitance or resistance on it. But when you get into the hundreds of millions of times per second that the signal is alternating, those start having more of a factor. So what normal designs would work for 121 megahertz by choosing out certain values, when put into reality, we were getting values more like 90 megahertz, centered around the passband. So that'll take some trial and error to make sure that we have a good working design for that filter. Once that's done, we should be able to produce nice, clean sine waves from the antennas. And the next would be going into the phase comparison. And this is probably going to be the hardest part of the whole thing. If we can get over this hump, then I think we'll be set. I was doing some initial testing, and the results weren't great. It's just because of an environment. I'm doing all this testing in like a lab area, which has a bunch of equipment all around, all sorts of surfaces everywhere. So when you send out a signal, it can bounce off those and then hit the receiving antenna at a variety of directions, meaning that the signal is not going to come in at a clear or as clearly as you'd expect it to, or as in a straight line always. So there's a lot of interference, and it wasn't producing great results in all directions. Sometimes it was producing really good results, just like using an oscilloscope for initial testing for the phase direction. But so next step for that is to do more research to try to figure out a good design. But now we also have the actual transmitter, so I don't have to use like a jank, just homemade one. So this will be a lot easier for testing. But I want to try to set up a triangular array that mimics the one on top of the boat, and try to get some measurements off of that. Because as long as we can get some consistency, then we could just measure the different values, different phase differentiation values from different angles, and then create a database of that, which we can map using some program. So that's the biggest hump that we need to get over, is the being able to get a working phase differentiator circuit going. But yeah, so that's navigation update.
Yeah, and so as you can see, Alex definitely knows his stuff. Alex has been primarily working all of this up in Atlanta, Georgia, at Georgia Technical, and or the Georgia Institute of Technology, if I may. I'm sorry, that came out horrible, but yeah. So Alex has been making good work on that. He's already got multiple antenna prototypes completed, and it's been going steadily but well at the same time. It's pretty good work he's doing up there. We're very thankful for his assistance, because I don't know about you guys, but I understood maybe 87% of the words he said. It's just Alex is definitely advanced in some radio knowledge at this point. So hopefully those will.
I've got a couple quick things that I can show as well. I've got the antennas in front of me. So these are the 3 different antennas we've got printed so far. So they're all wrapped around identical 3D printed molds with little indents for the wire, so we can replicate them as ideally as possible. And then here was the start of this was the bandpass filter. So it's using these tiny little SMT, I think it's nano Henry inductors and picofarad level capacitors, which are really small. But we got that one it was designed for 120 megahertz, but because of non-ideal behavior, it ended up producing a 90 megahertz bandpass filter. But yeah, so I just thought I'd show some of the little evidence of the work being done.
We definitely like seeing those, that's for sure. Let's see. Okay, we've got 2 more questions coming up. Alex, thank you for the navigation update. That's awesome stuff. That's good news, and very, very thorough there. It's almost like we almost know what we're doing. It's good stuff. All right, we've got our next question. Is the EGgBOAT solar powered, and how much weight can it hold? I'm going to answer the latter of that first. EGgBOAT has been designed to carry 2 liters of water, and doing that we can kind of get a weight equivalence there of 4.5 pounds. I believe is the right weight for that. And so that is the desired weight. When we tested the boat in the water, it was able to attain what it was a pretty ideal waterline buoyancy level from the test at that weight. So that's pretty good. We've got an extra calculated estimated 2 pounds of clearance past that, so we could likely take up to 6 pounds. But basically, the farther you go beyond that is the farther the boat sinks into the water due to the buoyancy laws. So you don't want to weigh it down too much, because you see more drag the more every little bit that the boat goes into the water. So keeping it around 5 pounds is probably the most ideal point of weight. as for solar power, Josh, are we doing solar power right now?
Currently, we are not doing any solar powered, so our boat is ran off of two LiPo batteries or lithium polymer batteries. And these batteries are widely used in the world of radio control. So anything from like RC boats, RC planes, it's a very common type of battery. This battery used with our watercraft gives us a ton of range and time to use, which is really nice. When we did our testing in some of the videos that you saw, we were pushing a person, we were doing all sorts of circles and running the motors. And after probably, I'd estimate around 15 to 20 minutes of continuously running the motors, our lithium polymer batteries were still at 87%. So this is exactly what we wanted to see, exactly what we hoped to see. And so that's the method we're going about it. Will EGgBOAT ever become solar powered? That's a great question. It's not exactly a requirement in the NASA challenge to make that so, but it is a realistic expectation, as say it was out in the ocean waiting for its mission, to have a continuous power supply to kind of be helping it out. So I could see that being an iteration that could happen, say this project ends up going further.
Yeah, I think that was the perfect breakdown. I mean, if I was going to go through that, that's what I thought in my head when I first read the comment too. So, yeah, it's definitely a possibility as a, say, post-challenge, once we go down to Houston in June, if we did get tasked with making EGgBOAT better, that would probably be one of the most ideal things to do, because once you increase the power capacity, you increase the range, and any more range you can go or time you can be in the water is obviously going to be beneficial to the operation. So, thank you. That's a very good question. So, our next question: have we considered a bilge pump? I'm gonna pray that I said that right. I'm just estimating that word, but I do know what that is. That would be a pump to evacuate water from the inside of a hull. Now, have we considered these, Brian?
So we have the many options that we do find. They don't last very long, and so our main priority is just waterproofing the holes as sorry, as well as possible before we actually buy into the pumps. That's also another source of power drain. That's another thing that we'd have to code if we chose to do, say, a water sensor, so that way it only activates when the sensor is so high. But that is something we have considered, and it was in our proposal if need be. So it is there. It can still happen, but as of right now, it's not looking like it's gonna happen.
Yeah, so I feel like the ultimate hope would be to pray that we don't ever need to rely on such a thing, which keeping water out of EGgBOAT would be very optimal. But Brian's right. It actually was on our proposal to have at least one pump in each of our hulls to either be programmed to run with water sensors, which also made it onto our proposal list, those being controlled by our central computer, where if they sense water, we run the pumps until there's no water sense left. So that was a hopeful part of our proposal, but it's looking like we may not need that. We may put it in if we have extra time. We're seeming like we'll have a couple of months to definitely reinforce the build quality of EGgBOAT, so we'll definitely keep that in mind too. So, if you guys have any more questions, please feel free to post those in the live chat. We'd love to hear from you. Absolutely anything, whether it's the simplest of questions like why is it named EGgBOAT, or why'd you choose your colors? We don't know if we have an answer for everything, but we'd love to.
We can at least try.
That's right. So
we'll give you an answer.
I feel like while we wait for some more questions to hopefully pour in, Justin, I believe you have an update for us. Would you like to give us a little bit of an introduction here as to what's about to
All right,
go down?
To grace your guys' viewing presence. Right. So as previously mentioned, I'm the guy that has 3D printed the majority of the boat, and of course, got the pipes to actually put it together and whatnot. But the thing is, recently they decided we want to make the lids more accessible to astronauts with really thick and big gloves, or just easier access for our lids. So therefore, we did some remodeling of the lids, and I made them. The thing is, I was told to make a video for it. Now, as you can tell by what I'm wearing, which happens to be an Eggman outfit, I went a slight bit overboard in the level of cringe that this video took place in. So, I'm calling it as I saw it. But I've decided to make it interesting, just so that way it was fun to watch. Not very long, but I hope whenever they show it, I hope you guys enjoy it. It was just a little thing to show my process and how I think about it and how I put it together. So, yep, that's what I did.
Let's hop into that video.
I feel like it's time to see this video update that has been previous to this meeting sent over to me. I briefed the start of it. Absolutely watched through this. It's the right video. It will play now. If you didn't have popcorn before, it's probably the best
You're gonna
time
want
to
some
do it.
now. You're gonna
That's
want
right.
some now.
Alright, let's see that video.
Alrighty, gamers. Today I'm going to be showing you the coolest build of all time. I'm going to show you guys how to make a tree explode with the minecarts of TNT. So first things first, we got to do the. Oh wait, hold on. I got a Discord. Hold on. Oh, Eggman. What is this?
What did you want me to... Oh. Ah, I see.
Alright, well, I guess I better get started.
Wow.
Good.
Wow.
Such great cinematography there.
5 stars. That
Informational and
and the
entertaining.
Oscar nomination goes to Justin. Wow. Oh.
Alright, so
That
now you
was
guys
amazing.
have seen some very compelling visuals on our manufacturing process. We've got some more
Yep.
questions. I feel like we'd love to answer these.
Yep.
I didn't watch through that whole video, but I watched enough to have a clue
I did.
as to what was
I
going on.
watched through it. I approved it.
Brian ran through it, said it was good, so here we are. Let's see. Our first question post Justin's video is, who came up with the name for EGgBOAT? If
I
you
did.
guessed Brian, the trivia answer was in fact Brian. Brian came up with it. Brian, what does EGgBOAT stand for?
So EGgBOAT stands for Electronically Guided Buoyant Optimized Autonomous Transport. Now, how we came up with that was Jacob was already working on the lid. We didn't have a clue what we were going to name this thing. I looked at it, I was like, that looks like an egg. And I spent
started
the
to cry
next
at that
couple
point.
of days
It does look
trying to come up with an acronym?
Yes.
An acronym?
Yes.
Yeah. I came up with what is now EGgBOAT. The small G is silent.
Yeah.
It's just there to finish egg.
Yeah, it's just for fun mimic
So,
purposes.
yeah, that's how we came up with the name EGgBOAT.
Yeah, so EGgBOAT's now deeply rooted in our history. It did come about around that original design, which has not changed one bit. EGgBOAT is still very egg-shaped, as you can see from some of the videos we showed previous to this. But EGgBOAT will forever maintain its beautiful name. Alright, so we've got our next question. Have you considered using a wave energy converter? Going to assume that by that you mean a generator based off of the kinetic energy stored in waves.
It's a cool concept, but no, we haven't considered it.
Yeah, so it hasn't been considered by us. I feel like the hardest thing for us to consider that via would be the fact that in most projects where I've seen that used, it's definitely on a larger scale for massive power production. There's a couple of very interesting proposals that have been shot out and testing rigs that have been made for coastlines to generate power off of waves alone. And so those are very cool, but a lot of those videos that I've seen, they have a lot of these buoys anchored to the ground. So without hooking something to the base of the boat, you'd have what is likely a larger structure built around EGgBOAT in the chance that you did make such a thing, and we have a size requirement that we have to first attain to. But if we were allowed to, say, go outside of that size requirement, that it's feasible. I feel like the solar power would be the easiest option to go through, arguably.
Definitely
out of those
solar.
two.
Another problem that you might consider with the wave energy generator is that EGgBOAT is moving. So what you're ending up trying to do is make a perpetual motion machine, and it would not work. You'd end up using the same amount of energy pushing EGgBOAT as what would be produced. And so you're more at a net negative than anything.
Yeah, so I believe that if you wanted to use it while it was in motion, Brian's right in the sense of if you had some sort of a frame underneath, it's likely that the drag from such a thing might slow you down more than your energy costs. But it's definitely if you haven't seen concepts of wave energy converters, definitely look them up. There's a lot of interesting proposals going around right now for that. It's one of the new green energies. It's honestly, I find it very interesting how we can just consume what is essentially a constant form of kinetic energy. So that's a very interesting topic there. We've got a new couple of questions here on should we use a gyro to control thrust. And now a gyro is usually a gyroscope would be implemented into an RC circuit or an RC control system to be able to account for different motions, which there would be a lot of while we're out on water. Josh, what might be some advantages or disadvantages to that solution that you might see in there?
When I think of the gyro, for our project, once we have the navigation set, we really shouldn't need one. So with the navigation, um, we won't need a gyroscope to compensate for any movement left and right in the water. The navigation system itself should have the ability to do that, to correct based on whether it gets pushed by a wave, whether one motor's lagging behind a little bit, or we're having any sort of issues there. The navigation system has the ability to tell the watercraft, hey, we need to go continuously in this direction. Now, a gyroscope for our testing purposes, if we are looking to do longer time tests, longer, broader range tests, could be pretty useful. As we saw in the videos earlier on, if you didn't see them, go ahead and look back at some really awesome footage of EGgBOAT. The boat wanted to steer to the left continually. So using a simple RC gyroscope, we would be able to help ourselves out with testing a little bit just to see what a true dynamic could work like with that. But for a final product, I don't feel that a gyroscope will be necessary.
Yeah, I would agree with Josh. There's definitely a point where it could be useful previous to the implementation of our navigation computer. Like if it was just in the remote control circuit, that might become useful at least in the yaw plane would be very useful. So it would be useful there, but once we have the navigation in, the hope is that the navigation system will correct for that, as the radio beacon source would be fixed compared to the direction of EGgBOAT being counteracted. So we've got quite an elaborate question posted here. 1 EGgBOAT good, 6 EGgBOATs on patrol even better. Sounds like a meme format there, but do you envision more than 1 EGgBOAT present at splashdown? Will that be a part of your pitch to NASA? So I've kind of had some inner arguments on such a topic, but I feel like a good way to approach this is to consider, why is EGgBOAT useful? And it's useful in the sense that it's not controlled by anyone, it's not driven by a pilot, it's driven by itself, and it's awfully cost efficient compared to, say, buying an entire naval vessel, right? And so you're like, okay, but if EGgBOAT is moving towards a capsule and reading that signal, couldn't a Navy warship or a Navy rescue Coast Guard ship be able to get to them as well? And the answer is yes. So you have this race now, but you can enter this zone of efficiency where if you were to put at least a bunch of EGgBOATs in the splashdown area, they're not allowed to post up Coast Guard ships and Navy ships within a certain radius of zone, because within that zone, obviously, if a capsule was to splash down on top of a Navy ship and go clonk, there'd be a couple of issues. But EGgBOAT doesn't have many people in it, nor is it of detrimental size to the capsule. So, in the absolute worst case scenario that the capsule landed on an EGgBOAT, it wouldn't be the end of the world. So you could have a bunch of these EGgBOATs downrange of a capsule splashdown zone. So, the idea is, yes, many EGgBOATs would be the overcoming positive way to beat, say, the existing measures we have right now to provide help to stranded astronauts. So thank you, Uncle John, for all your questions. We definitely appreciate it. And thank you everyone that has asked questions. If you do have any other questions, please post those now. We'd love to answer those before we wrap up our stream here. We don't want to keep you guys on too long. Thank you to everyone watching too. We definitely appreciate the viewership. It's very helpful to us, and we like showing NASA that we get some engagement around this, and they like seeing that too. So thank you, everyone. All right, now I think our best solution here to use our last bit of time is, what are we doing looking forward? What's our immediate next goals? Justin, I feel like you have a good overview right now of the physical things happening.
Well, I believe next up on the agenda is to get the finalized upgrades ready to go and shipped over. Get it built, put on. I believe it would be last minute tests, making sure antenna is fully assembled and built on there, and that everything should be running smoothly. And then I believe we're actually pretty good, well off, not gonna lie.
Yeah, and so once we get some additional 3D parts printed, we're working on a hatch system that will hopefully be easier for astronauts to open up EGgBOAT to get to the useful necessary supplies they need. Once we get done with that, things like finishing the radio system is going to be primary goals. We're also going to work on the kill switch system that is required of the proposal. Hopefully, maybe do some additional redundancy parts within our proposal. Things like the build pumps that haven't been completed yet, just to fulfill all of the requirements we proposed to NASA originally would be the main goal. And once those get done, pushing off of that and making EGgBOAT as good as it can be before we ship it out the week of May 6th would be ideal. We've got another question here. Will there be a sequel to the famous video? I asked for clarification in chat on which video in particular, because we've got a lot of those circulating right now. What video are we talking about here? Which one is this?
My first thought was Justin's video.
Yeah, I'm thinking Justin's video.
That's
too.
where my head went.
Well, I'll have to perfect my Irish jig a little bit more, first off. And yeah, there was a 20-minute tutorial, guys, on YouTube. Go look it up. But
also gotta wait on Jacob to finish the lid.
Yes, we need to wait for that. There could be if I have to print some more stuff. Other than that, we'll find out eventually. Aye.
Yeah. I would say hopefully to such a question. Before we roll out of this, I want to hear from yeah. All right, it was Justin's video. We got it right. Thank you.
Nice.
The clarity has been found.
Guys, I'm famous.
He's already famous. He's got famous videos from a famous man. Before we wrap this up, I do kind of want to go around really quick. It doesn't have to be super long here, but starting in the way we introduce ourselves. What have you gained, and how do you feel about the competition so far? I've heard or at least not EGgBOAT. EGgBOAT doesn't control us. NASA does. NASA likes to see some reflection about the competition. So I feel like this is a good time while we're here with our audience to share. What is it really like to be in this competition right now? Alex, you might have the first insight here.
Yeah, for the first part, for what I've learned, it's been a ton. I mean, I knew nothing about radio frequency or antennas or anything regarding wireless propagation going into this. So I've learned a ton about that. Everything that I've been working on to design the system has been completely just self-taught since we've started working at the competition. What are my thoughts on it so far? I mean, I really enjoyed the type of format and the topic itself because they're really interesting, like multifaceted problems when it comes to navigation, when it comes to mechanical, when it comes to autonomous system. So I really enjoy that. Looking forward, a bit nervous about how the navigation stuff will turn out, but overall, pretty optimistic. I think there's been quite a bit of research outside of us done that has shown that our navigation technique works. So we just need to be able to implement it well. So,
Josh, what are you feeling about the competition right now, boss?
My biggest takeaway for this NASA challenge so far has been our ability to work together as an intercollegiate team. Like, communication is such a hard and difficult aspect of large groups, people working together on projects. And the fact that we've been able to work on this project being at multiple different colleges across the country is astounding to me. So getting this opportunity to work on the communication skill, to be able to keep up with everybody, to to travel to get to actually be there for live testing of the watercraft has been one of the coolest opportunities ever, and it's really, I feel, helped grow my communication skills working with a team that's across the United States.
I think that's a pretty good way to wrap up that bit too. Is we've definitely had quite the reaches to make from that, and so reaching all the way to Texas now across a single video chat. Justin, what have you taken away from the competition so far?
So on my end, it wasn't really about learning anything new, but rather perfecting a craft. As I've mentioned, I'm the guy that built the thing. But the thing is, fancy fun videos aside and having fun with it, as a project as a whole, it's been able to give me an opportunity to practice what I've learned a little bit on making blueprints and more or less getting my 3D printing skills and CAD skills nailed to a T. I've been able to try to nail it to make the best possible boat, and although it still did leak and I had to epoxy it, which they eventually did Flex Seal, it was better than what it originally was because trust me when I say 3D prints like to leak, they really like to leak. But other than that, there's been that. Plus, not just that, but over here in Texas, where I live, the community isn't big on things from the outside. So the fact that I've been able to do a project like this that's out there with NASA and Florida and wherever else everyone is, it's for us over here, it's actually been big and a lot of people like it. So well, that's how it's been for me.
Brendan, so far, what do you think about the competition?
Well, so far my impression has been, first of all, it's been just great to be able to work with you guys. You've been a great team so far working on this project together. I think it's been a great experience to be able to work on a team on something as large as this project is. It's kind of great to be able to be working on something that's not only fun to do and be able to experience more what kind of engineers get to do in the kind of in their daily work when they're getting to work with teams on projects such as this, but at the same time get to work on a project that has like real world applications, and the ability to assist NASA with their missions. I feel like it's something that a lot of other competitions or projects you work on might not allow you to be able to do. And so I believe that this experience that I've had with Micro G and everyone else is having here as part of this competition is just that it's allowed us to be able to develop as better team members and be able to contribute to something much larger than ourselves in a meaningful way, and at the same time just have a lot of fun.
Yeah, I'm kind of alongside both Brendan and Josh over there with like working in a group across different states. Like we're 1,600, no, yeah, 1,600 miles away from even Justin, and getting the boat here from over there is kind of amazing to see. and that all of this has been happening pretty smoothly and fluently. Um, it's definitely a different experience, especially since I come from the same part of Texas as Spaz does, or Justin. Sorry, that
You're good.
nickname stuck with me. But like he said, it's very not looked at in West Texas. It's kind of just, if you do it, you're kind of cool. That's a rich kid thing to do, and so it's it's a very different experience from what I'm used to.
Yeah, I think Brendan and Brian and everybody here has definitely spoken the true words that NASA has given us an opportunity to learn quite in quite realistic terms what it's like to be in this kind of an industry. You've been given this this pitch for an idea that you have to propose something for, the classic RFP, request for proposal format, and once you propose that and they accept it, you're like, oh wait, okay, we have to actually get this done now. And like an actual big company that you might see, somebody with multiple facilities across the United States, you've got people from different departments of those facilities working together on these different things, and we're all shipping it to each other, and we're shipping things from Texas to Florida and Florida to Atlanta, and then we're going to ship things back and forth, and then all the way back to Houston at the end of it, back to NASA. You start seeing all of this physically come together, quite literally, and it's impressive how fast things can get done, but at the same time it's humanizing, because we've got a lot of things that we wanted to be done already, and it's like, okay, we need to get these things done now, we need these things done faster, but it's like, at the end of the day, you do the best you can, you put your best foot forward, and we're going to make the best product that we can. So, very proud of this entire team and the work everybody's put in. It's been very impressive and good, and I think everybody is very happy of what we've been able to accomplish so far. So, and that's possible thanks to people like you guys watching. Thanks to our donors always for the help you've always given us with both financial and supportive ways. We appreciate all of the support back home and all of the support everywhere for EGgBOAT, and we're going to do the best we can to get everything wrapped up and finished with a nice little bow just for you guys. Looks like we've got one last very informational question here. How many people did you chase out of the pool? Brendan, you showed up first.
And you know, you're probably gonna find this shocking because on the day we did it, the temperature was amazingly hot. It was beautifully sunny outside, but interestingly enough, we didn't chase out anyone out of the pool. As soon as we were getting EGgBOAT ready and about to bring it into the pool, the one guy who was swimming in the lanes near where we were going to be testing just got up out of the water. I don't know why, but he just decided to move on, and we were like, okay, well, I guess we get the whole pool to ourselves. We don't have to kick anyone out. So yeah, so it worked out actually very nicely. I mean, we got there just as the pool was, I think, had opened for about an hour earlier. The lifeguard was just showing up and whatnot, and I guess because of the school we go to, no one was too shocked to be having us ask about doing testing in the pool and putting a little autonomous bot in the pool and going around while people were in there. So, yeah.
Yeah. It went too well in the sense that we really didn't have to kick anybody out. The lifeguards were fortunate enough
is too
to
bad.
give us our own lane.
I didn't get to kick anyone out.
We didn't get to be bouncer for the day, but...
You didn't get to run someone over with the boat?
Ran over me.
Yeah, we did we did run over Brian a couple times, but yeah. So I think this is the ideal place to wrap it up. We've definitely had quite the eventful informational stream here. Hopefully everybody viewing enjoyed it. Thank you very much for sticking with us. We've got one more thing. Way to go with doing all this on top of your studies. You guys rock. What an honor to be in the competition, and that it is. To be selected for Phase 2, I think we were all on Cloud 9 that day when that information was released, and ever since, it's, even in the hard times, it seems like this may be too much of a challenge to take on, but you're like, wait, but they chose us. They want us to do this for them. So, it is, it's definitely an honor, so we're happy to be here, I think is the right way to put it. So.
Very, very happy.
So, with that, I'm gonna play back our showed, yes, those videos that we're playing. I'm gonna let those roll out and conclude our stream here. Since people might have come in late, they might not have seen those, or at least you'll get to see them again if you haven't. So, from all of Eggman Robotics, thank you for watching. That, guys, that's when you like unmute and also say thank you. It was gonna be the moment. Thank you, everyone. We love all of our viewers. Thank you so much to our donors. Thank you, everybody, for all of the support. And with that, we're gonna let you guys roll out with some footage. We'll catch you in the next one.
Bye-bye.
Bye-bye.
Brian, you're on catch. Right side of the bird. That's why I brought this game.
Nice. Well, we know it moves. How fast can you spin it in a circle? It does tricks. What?
Wait, quickly, this is the most fast floating space symbol ever.
Oh, yes, it is.
You gotta get that color in it. Oh, that 360 can't focus.
Yeah, it is. I can stabilize it. Wait, that is quick for all the loading. Brian, you're on catch. Right side of the bird. That's why I brought this game.
Nice. Well, we know it moves. How fast can you spin it in a circle? It does tricks. What?
Wait, quickly, this is the most fast floating space symbol ever.
Oh, yes, it is.
You gotta get that color in it. Oh, that 360 can't focus.
Yeah, it is. I can stabilize it. Wait, that is quick for all the loading.
Well, the R6 system. Actually, Brendan, you wanna go check it for a sec? I'm sure that it is.
Hey, Brian's gonna go for it.
All you, man.
Now we're directed straight down. Watch out, Brian. He's gonna run you over. Here you go.
It's kind of hard to change.
Brendan. Yeah, what if you try holding it in one spot?
That's half throttle.
Pushing Brian.
Hang on, at least we
This
know.
isn't full yet. That's 3/4. Don't go for it. We're not really black chest. It's pretty stable.
Nice.
What was that?
Haley is what that was.
That thing calls out.
Hold tight.
That's bad.
I mentioned the possibility of bronchitis recently that he was saying that this happens with other surgeries and basically I somehow spread the virus to my eye by
Like, try and, like, put some nose down.
in my eye or whatever.
No, just like
And that's why this guy turned to the
and do it with the bag too.
yeah.
Go back. Back.
So I just basically cleaned up
You can tie your side too.
Side to side.
later this
That's
afternoon
not-
after I go back home and get that.
Find the back pipe. Not
What I can tell, you know. When you look underneath, do you see the water going back out forward of the same insert
Going backwards?
when we go backwards?
It should. Oh yeah.
Yep. That's good news.
Using it as
Have
a
to let me turn it around
preserver?
once I get there. but-
How would that work?
I mean, it could be battery. Like, we just used all the battery on one side, but, ooh.
Alrighty, gamers. Today I'm going to be showing you the coolest build of all time. I'm going to show you guys how to make a tree explode with the minecarts of TNT. So first things first, we got to do the, oh wait, hold on, I got a Discord. Hold on. Oh, Eggman. What is this?
What did you want me to... Oh. I see.
Alright, well, I guess I better get started.